Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma, and today I'm with Alice Ryhl. Of course, I know I said that slightly wrong, so she will be correcting me in a moment because my Danish is not so good. She is a core contributor to the Tokio ecosystem, I would say, since Tokio has a lot more things than just Tokio itself. Let me just spin it over to her. Maybe, Alice, you can help me with your pronunciation and also give a little bit more of a background about yourself. So why don't you go ahead?
Yeah, all right. So the way to pronounce my name is Alice Ryhl. And so I'm currently one of the core contributors to Tokio. And so basically, if you send a PR to Tokio, it's probably me who is reviewing it. And
and that's it? So when you review these PRs, right, actually, what is the process? Because I've heard different kinds of processes for contributing to projects. Like for one, I know one project, the Elixir project, what they like to do is that people would actually submit a proposal onto Google Group, and then it would get reviewed, and then they would say, okay, why don't you go ahead and have a try? And the reason that they do this is because they don't want somebody to give a bunch of time to something and then just get it shut down because they say it doesn't fit with the way that the product's going. Like, what about for you guys? Do you guys just say, just submit whatever PR you want, and then we'll either approve it or disapprove it, or what?
So it depends a bit on the PR. So, I mean, if you're just making a small fix, then they should and do just submit it. And if it's just a small fix, we can usually just approve it. And for larger projects, it's usually best to talk with us first. This could be on the issue tracker, but we also use the Discord quite a lot, and we can discuss there if we need more, like a longer discussion about the exact shape.
So what is it with Rust people in Discord? Like, I'm not against it, just it seems like every community has their own kind of channel. I think like Rails is usually on Twitter, and it seems like Rust is always on Discord. Like, do you have any idea why Discord is the channel for Rust people?
No, not really. I mean, I think it just caught on, and then people keep doing the same thing. I mean, I think it's nice that all of the Rust servers I'm in are in the same place, so I don't have 1,000 clients running, and I can just have one or two.
Yeah, I agree about that one. I think, for the most part, I think most of my stuff's on Slack, but yeah, for Rust, it seems like it's always on Discord. I don't mind. It was just a little bit curious if you knew why. Okay, so like, for example, if I'm interested to submit some kind of feature, I could just blast out into the channel on Discord or create an issue and say, this is what I propose to do. And then you guys would say yay or nay, or who would kind of give the thumbs up to this one?
Yeah, I mean, sometimes sometimes I will just make the decision. Sometimes I will also bring in some of the other Tokio team members. It depends a bit on the details of the feature. And yeah, I mean, open a feature request on our issue tracker. That's a good way to do it. I mean, so when you post on Discord, that's nice to get like some initial feedback and some discussions, but I do think that discussions where we should remember what we discussed for like the next day should probably at least be summarized on the issue tracker and not just exist solely on Discord.
Yeah.
We do have some cases where we have discussed it on Discord and then I've gone to the issue tracker and say, we discussed this on Discord and here's what we concluded.
Oh yeah, that's always good to have like a summary and make it clear for everybody and kind of written down so everybody can take a look in case they forgot, right?
Yeah, absolutely.
But now this is quite interesting, though. You mentioned to me that you're actually a student, right? So you're a master's student, I suppose, or are you still studying your bachelor's? Okay.
Yeah, so I'm doing a master's at the Technical University of Denmark. I just started my master's after finishing my bachelor's, and so it's a 2-year master's. Yeah, that's how it works in Denmark, and yeah.
Okay. But I mean, it's a pretty big responsibility to study your master's and also be really part of the core team, it sounds like. Like, how did you fall into this kind of position?
Well, so the way I really got involved with Tokio was probably so before I got involved with Tokio, I was spending a lot of time on what's known as the Rust Users Forum, and where I would just answer questions that people are asking. And at some point, I also joined the Tokio Discord and did the same there. And then at some point, I started contributing on the GitHub repository, and it just kept going from there.
So you just kept answering people's questions, and it sounds like some people in the team noticed it and then just said that this person knows what they're talking about. We should probably get them on board.
Yeah, something like that. And I mean, I also started contributing to Tokio at some point. And it's just mostly stuff I've been doing in my free time.
Now, when you say contributing, right, I think answering questions is also like a form of contribution, in my opinion. Like, when you're saying contributing, though, it sounds like maybe you're saying contributing code, right?
Yeah, you're totally right. Yeah, it depends on what you mean by the word. But, well, so you say contributing code, and that's important, but it's also important to help people out, and it's also important to contribute things that are not code, for example, documentation.
Yeah, we were talking before we started recording, right? And you definitely mentioned that documentation is a huge thing. How about the docs for Tokio? Do you feel like you're in a good position, or you feel there needs to be more done, or what do you feel?
Well, I feel both things. The Tokyo docs have come a long way, honestly, but there's still so much more that we could do. I think so. Not the summer we just had, but the summer before, we spent a lot of time writing the Tokyo tutorial on the Tokyo website, and since then I have been doing various small improvements here and there. For example, there have come a lot more examples in the API reference, and it has gotten a bunch of more info. For example, I added some information about cancellation safety to basically all of the methods in Tokio. And similarly, I started writing some pages on the Tokio website that I call the topics pages. These are different from the tutorial in that the tutorial is intended that you read it from start to finish, but with the topics pages, the intention is that you can pick any one of them and read that one without reading any of the others. We only have 2 topics pages at this point, but I really do want to have more of them. And yeah, so unfortunately, it actually takes me quite a while to write them. So, I mean, if anybody out there wants to get involved with Tokio, I think helping to write a topics page would actually be pretty cool. And I would be happy to help out both with figuring out like what are some good topics and how should you explain it, and well, reviewing the pros.
Okay. Sorry. So the topics is kind of like more in depth versus like the documentation where it's talking about each single method, right? So is it written like a story or like a tutorial, or what's kind of because you said the pros, right? So that means there's a specific format to it.
Yeah. So a topics page is basically a short tutorial. A tutorial that fits on a single web page about a specific topic. For example, one of the topics pages we have is how do you implement graceful shutdown of a Tokio application. And this does not really fit in the API reference because, it's not like a specific method that we're documenting here. We're documenting how do you do this.
So what kind of topics are you covering right now, and what kind of topics do you think need to be covered to have a good base of topics within the documentation?
Yeah, so the topics we have now are, as I said, graceful shutdown. And I also have a few blog posts that are very similar to these topics pages. For example, I have a blog post on what is blocking the thread, and I also have another blog post on actors, which is a specific design pattern. And I'm actually thinking of moving the blog posts to the Tokio website and turning them into topics pages, so we get a few more. And one article that I'm currently working on is an article about how do you correctly use logs, like a mutex or an RW log in async code. And when should you use the blocking log and when should you use the async log in Tokio Sync?
Yeah, those definitely. Okay, that's a pretty interesting way to write it. Okay. Yeah, I was just looking at the topics right now. Like I said, or like you said, there's just two right now: bridging with synchronous code and graceful shutdown. Those are definitely good to have.
Yeah, and I mean, if people want to get involved, just ask me on the Tokio Discord, and I can find various topics that would be good to write about, and I would be happy to help you with that.
So, are you also the one who actually checks all these topics? And it sounds like you're also the one who actually wrote all the topics. Is that right?
So I wrote the 2 topics articles. When it comes to the Tokio tutorial itself, I'm not the only one who. I wrote some of it, and Carl wrote some of it, and so on. But I was definitely involved with the tutorial as well.
Okay. Yeah. So, what is like your favorite part about contributing to Rust? Is it writing the docs? Is it writing the code? Is it answering people's questions? What do you usually like to do? What's your favorite part about contributing?
Well, I mean, so answering questions is one thing that I do a lot, and it's a thing that I find very easy to do in, like, if I have a bit of downtime, or and there are some other things, for example, writing a topics page. I find that quite interesting, but it also, well, it takes a lot of effort, honestly, to do it. So that's why there are not that many of them. And when it comes to writing code, I mean, that's also a bit in the, I mean, it requires some time of more focused effort, but I still enjoy doing it.
Yeah, true. So, being a student and working a job, right? What do you actually find time to actually do all this kind of stuff?
I mean, I guess on the evenings. So I do also spend some of my time at my student job working on Tokio. But
Okay. How long have you
yeah,
actually been working with Tokio?
I got involved with Tokio around, I think it's 2 years ago at this point. I haven't been involved from the start, but yeah, 2 years ago or so, just around, it was a bit before async await, like the syntax, got released. And yeah, I have just been becoming more and more involved since then.
So, comparing when you first joined to now, is there actually a lot of changes that actually happen in terms of, like, of course, it's changing underneath the hood, but is there changes in like the API or like the way you thought about the way Tokio runs since then?
Yeah, I mean, Tokio is still changing. I can give some examples. So when it comes to the core Tokio crate, um, some of the things that we have worked on over the past year are, for example, named pipe support on Windows, or um, there's a feature called the co-op system, which can prevent certain behavior where the runtime is favoring one task much more than the others, and stuff like we had like we have this method on the channel called try receive, which there was a bunch of trouble with, and we didn't have it for a long time, but eventually we managed to properly implement it, and now it's there. We also have some, for example, we have tried to implement some stuff to. So one of the disadvantages in async is that file support is rather poor, but one of the things we have tried to do is that it turns out on Linux, you can ask the kernel to try to read from the file, but then like do it in a non-blocking way and just return failure if it can't read right now. And try doing that before we punt it to the thread pool. We haven't, it's not actually in Tokio right now because it's quite complicated to test that it's actually correct, and we still need, well, to do that. But yeah, those are some examples of things that are happening in the core Tokio crate. Another thing which is a bit wider than just the Tokio crate, but one of the focuses from our like the 1.0 release of Tokio, we had a blog post about this, is that in 2021, we wanted to increase the focus on visibility into the runtime. Like, what is the runtime doing? And this has involved several tools. For example, the Tokio Console tool is a project that it's basically like a task manager for Tokio tasks. That's one of the new tools in this regard. There's also a library called Tracing, which is basically a logging crate, but it integrates well with async code. And I've also been working on some metrics to like extract information from the runtime. This would be stuff like how much workload are these specific tasks taking up, how many times has the runtime parked, and stuff like that. And by the way, so if you're using Tokio in some sort of server in production, if you could use those metrics, then please try them out. They're currently unstable, but they should work fine, and they're unstable because we're not sure exactly which shape the API should take, not because we think that they're not production ready. And if you have feedback on which metrics should we have and how they actually work in practice, that would be super useful.
So these metrics, right? When you're saying metrics, you're talking about what kind of metrics are you actually measuring?
We are not measuring very many right now, but we plan to add more of them. So one of the metrics is just how many times have we pulled a task? And another one is how many times has the runtime parked? And here parked means like when the runtime says, I don't have anything to do right now, so I'm going to put this thread to sleep. So how many times has that happened? And it's also stuff like, so while the runtime is doing something, like between two parks, we will measure how long did that take and stuff like that.
Okay. That sounds pretty interesting stuff. It would be also cool if you can also have your own metrics. Like you can say, yeah, I don't know what the current with the API is and how that all works, but it would be kind of cool if you could just start defining custom events that you could just increment on your own. Then that would be also interesting, and you can expose all that. Is that actually possible, or this is really hard written into the ecosystem?
I mean, the metrics we're talking about here they require adding code to the Tokio scheduler to like record that this event actually happened. So so it's not really feasible to allow the user to add their own metrics in that way, but we do want to add all the metrics that people want to use.
I think some interesting metrics would definitely be, how long has the task been running? How long, how much memory has something taken? I don't know. I'm just trying to think what else would be useful.
Yeah, so some of the task-specific metrics. So how much memory is a task taking? I don't know how you would measure that. That would be interesting to investigate. But when it comes to stuff like how long has a task spent running, that's actually more the domain of tracing and Tokio Console, it turns out. Tokio Console will already today measure that kind of stuff. And it does it without actually have like support from the Tokio runtime. It is able to do it on its own, which is pretty cool. So the metrics are more like on the like worker thread level, and the tracing and Tokio Console is more on the task level. And those are different because with Tokio you typically have lots of tasks on each thread.
Yeah, because these are basically green threads, right?
Exactly.
The Tokio tasks. Mm-hmm.
Yeah, so a Tokio task is basically a green thread. That's just a different word for it.
Actually, I'm kind of curious about how this works, right? This is all preemptive scheduling, right? The scheduler is the one that kind of stops stuff from happening. So if I have a long-running task, like what's the benchmark until it says, okay, I'm putting you on pause and I'm going to run something else?
So this comes into both the thing called cooperative scheduling, and the co-op system also becomes very relevant here. So the thing with tasks in async await is that basically the Tokio runtime says to the task, hey, it's your turn now, and then the task gets to run until the task gives back control to the runtime. So the runtime has no ability to actually stop the task. And we call this cooperative scheduling because the tasks have to cooperate. And this is also the topic of my blog post, what is blocking? Because what I talk about here is blocking the thread means a task that doesn't give back control to Tokio. And the way I describe it in this blog post is that basically Tokio gets control back whenever you get to an await. So for example, if you use the sleep function from the standard library, then you are blocking the thread because you don't have an await. So Tokio cannot get control back. One of the really cool things that Tokio actually is able to do to make tasks like yield to the executor is using the co-op system. And so the idea is whenever you get to an await, it's not actually guaranteed that you're yielding back to the executor. That only happens if the await is not immediately ready. And so what the runtime does is that it counts how many times you have gone through an await without yielding. And if you do that too many times, it's going to pretend that this operation is not ready now, even if it would have been. And this can really help. Yeah.
Sorry, I was just kind of curious about how many times is too many. Is that configurable or that's something that's built in?
I think we use 128 or 256 or something like that. Ideally, you would actually be measuring the amount of time that has passed, but it's a lot cheaper to like count them. In my blog post, I mentioned that ideally you should not be spending more than 10 to maybe 100 microseconds before you yield. Yeah, so something like that.
Sorry, I kind of interrupted your thought. I think you were on something very, very, very interesting, and I apologize about kind of cutting you off. Do you remember where you were
at? Not really.
Well, I thought it's actually kind of interesting because, like I said many times on the show, I've been doing Elixir for a lot longer than I've been doing Rust, and they have a preemptive scheduler instead of a cooperative scheduler. And I heard from a previous manager of mine that cooperative schedulers can be a little bit not so nice because, yeah, like you said, you have to yield, right? If you're running something, you have to yield it yourself. And if you don't, you're just going to bog down the system with your own process. But I think that this is not such a big deal because with the async await, like you said, you can kind of get yourself a little bit out. So if you're using asynchronous code with async await, you can eventually yield back. Sounds like, at least if you hit 128 or 256, whatever you said, at the least, right?
Yeah, and the co-op system actually turns out to be rather useful for like real-world systems that are sometimes under a lot of load, because in those cases, I mean, you just end up with a loop that spins and spins and spins and spins because data is coming in so fast that there's always data to read. And this just prevents, it means that only one task gets to run. And it also has the consequence that then all the other tasks are suspended for a long time, which increases the tail latencies of the applications, which is pretty bad. So cooperative scheduling, you're right that it's not always so great because, so for example, I mentioned the standard library sleep function, which will block the thread, and if you use it, you're in trouble. But there are also other ways you can block the thread. For example, if you use a database library that's blocking, for example, Diesel, then you can't just do that in Tokio. You will block the thread. You can't. And you need to wrap it in spawn blocking, or I think Actis has a similar method called block or something. And you have to do that. Otherwise, and the compiler currently has no way to warn you of this. There are some efforts to actually introduce one. I'm not too involved with that, but I think that would be incredibly important because, I mean, I wanted to sleep, so I just put asleep, and then it doesn't work. I mean, that's kind of not great.
Okay, so you're saying there's some effort within Diesel to solve this problem?
No, this is in the compiler. So, like, for example, there's an annotation which called must use, for example, on result, where if you, like, it says, it gives you a warning if you don't use the return value of a function if it has such a type. And there are some efforts to introduce something similar to blocking functions. So you get a warning if you use them in Asian code.
Now, here's another good question, right? If you're defining the word blocking, I mean, every time you run a piece of, even 1+1 theoretically is kind of blocking, right? To a certain extent. But I mean, because you're doing something, you're not yielding back control. So how would we define this kind of thing? Would you say, how would you define it?
It's a good question, and it's also an important question. And especially for things like the standard library mutex, it has a lock method, and it's blocking, right? But I mean, what if it doesn't block for very long? What if it blocks for 1 microsecond? Is that blocking? Not really. Maybe. So the blog post I give a definition here that if you block for more than 10 to 100 microseconds, then you're probably blocking. And notice that's microseconds, not milliseconds. And so if you're less than that, you're probably good. And if you're more than that, it's probably not so great. But in reality, this is a gray area, and it depends on your application. So something interesting is that there have been a few people who have used Tokio to actually run blocking code just as an ordinary executor. And of course, the consequence they get from this is that their tasks could be suspended for seconds without doing anything. But they say, for my use case, that's okay. So they're actually using it kind of like Ryhl, where the tasks just runs whenever there's free CPU time, which is kind of interesting. Of course, you can't put anything I/O related on such a task because it will just, it will get super delayed because of everything else.
Oh, this is a good question. Sorry, I don't know this, so I apologize if you think that I should have done more homework. Now, how many threads get spun up? Is it like one per core? And also, I'm guessing you must have specific I/O threads, right?
So the default is that Tokio will use 1 thread per core on the machine. Basically, we just call the num CPUs crate and ask them, how many threads should we be using here? Of course, this is configurable. Tokio has both the main macro, which has it as an option on it, and you can also use the runtime builder, and it's an option here which you can configure. When it comes to I/O threads, that's actually part of the runtime. Because remember that I told you about parking? Parking is what happens when the runtime says, I don't have any work, so now I'm going to put this thread to sleep until something happens. And the way it goes to sleep is that it asks the operating system to say, please wake me up when something happens on any of these I/O resources, instead of just calling like a sleep function or something like that. And this means that the I/O reactor or driver, we call it, actually runs on the same thread as the thread that runs the tasks themselves. And it's also why you have to use, if you want to use Tokio, you can't just use the standard library I/O types. You have to use the ones in Tokio. And this is exactly because of the way Tokio parks. It needs to know which I/O resources to add to this, to the operating, the syscall that is using to sleep, because otherwise it won't wake up when your socket has a readiness event.
Oh, okay. Yeah, I was always kind of curious about why you guys have your specific versions, but I thought it was because you need to add some, because I don't think if I remember correctly, and maybe I remember wrong because this is a couple of years ago, when I worked with Tokio. I think most of the operations in standard library they're all blocking, right? And so that's why you would have to use the Tokio ones. That's what I thought the reason was. But
That's
now you're
another
saying
reason.
not even, that's another reason, yeah. But now you're saying because if you're not using some threads, they can go to sleep. And the only way to wake them up is to use the Tokio specific ones because they can look for that and wake them up if they need to. Did I say that correctly?
Yeah, more or less. So there's another strategy, and that is to spawn a dedicated thread for your IO operations. And I mean, when you do this, then this other thread will handle figuring out when does an IO operation happen, and it will then send a notification to the Tokio thread that's sleeping. And so this is another way you can wake them up. Tokio has some sort of inbuilt way where if you call wake from one of the threads outside of the runtime, then you will also wake the thread up. And it's also a similar story for timers. The way Tokio implements timers is pretty simple. This syscall that it uses to listen for events on the socket, it uses a timeout on the call, and the timeout is just the smallest timer in your Tokio runtime.
Okay, that's pretty interesting. What can we actually talk a little bit more about what does it mean when a thread goes to sleep? For sure, I don't know enough about threads, about sleeping and awake, right? So sleeping and awake threads, that's something that's OS really, right? So what is this sleeping thread? Is that actually being written to disk and then kind of coming back to life later on, or what is it exactly?
So basically, in the standard library, that's a function called park. And this is what I talked about with parking the thread. It's basically your operating system, when a thread gets parked, will simply stop giving this thread any CPU cycles. And so it's important to remember your operating system is doing something similar as what Tokio is doing, where in Tokio, we're scheduling the tasks, but the operating system is doing something very similar to your threads, where it will alternate between which thread runs on each CPU core. This way, it will give every thread a time slice, we call it. And any threads that are sleeping or parked, they don't get any time slices until they wake up again.
Okay. All right. That's interesting. So the runtime manages all of this.
Yeah, the runtime will take care of calling park and waking up at the right times.
So you're saying park PARK, or are you saying pack PACK? Maybe I'm not hearing correctly.
PARK. It's like parking a car. You park the thread.
Okay. You have a little bit of a Boston accent when you say that. Now I understand. Okay. Park thread. Okay. So this is, yeah, I see. Actually, I haven't heard this term before, so it's very interesting. It seems like this is also in Java. He has a spinning execution. Mm-hmm.
Yeah, it's not a Rust specific thing. But the standard library has a function called park. When you call it, the thread just goes to sleep, and then the standard library also has an object called a thread, and you can get it by calling thread.current, and you can send this object to another thread, and then that other thread can call onPark on the thread object, and then the thread will wake up.
Okay. All right, I got that. Kind of going back to more about the ecosystem, right? So Tokio is really a massive project, right? You kept mentioning like the main crate or the core crate. I forgot what the term was that you used. There's also the tracing, which I know we mentioned before, and now there's this console one. So I'm aware that you didn't spend a lot of time like really working with it, but you do actually said that you advise people to use it to help debug things, and you've also kind of worked with people on debugging their projects using the console one. So what can you kind of tell us more about this console?
Yeah, so I don't work on the console myself, but it's a very useful debugging tool that I tell people to use. The primary place where I'm telling people to use it is if they have symptoms of blocking the thread in their program. And those symptoms usually manifest in something like, I send a message on my channel and the receiver doesn't receive it. Well, that's probably because something is blocking the thread and the receiver task is not able to wake up. And the way you debug this is basically there are a few ways, but one of the easiest ways is to use the Tokio Console, because the console is basically just a task manager for your tasks, and it will tell you if you have a thread that's blocking the thread, like a task that is blocking the thread. And one of the problems with blocking the thread is that it's often pretty difficult to figure out which task is doing this, and the Tokio Console can tell you this. And it's also useful for other things. For example, if you're just learning and you want to understand what are my tasks doing, like what's going on, the Tokio Console can be useful because, it gives you a view into what's actually going on in your runtime, and it lets you visualize everything you have spawned. I'm sure there are also people who use it on production servers where you will then log into the server if you notice some sort of problem, but I don't have any experience with that.
Actually, I also want to kind of go back to the console part, right? So what am I looking for? Like you said, I think you said there was if a task is hogging a thread, how would I know that? Is it there's a tick of how much time it's been using, and we're saying that this is going to be too much time? Or how do we actually know that it's hogging a thread?
Yeah, so the console is going to list something like the last poll time, like how much time. So just some terminology. The way that Tokio starts a task to run again is that it calls this function called poll, and we call this polling the task. And then the way it works is when the task yields, because it gets to an await, the poll function will return. And so the console, it's going to be timing how long did this call to poll take. And it's going to list these times somewhere in the console UI, and you can see them. And then if it gets really large, like maybe a second, then it's going to get highlighted, I think. It should at least be obvious that, and I'm pretty sure that they also do something where they show the total amount of poll times, but that's, if that gets large, that's not necessarily a problem. The problem is when a single call to poll takes a long time.
And you're saying a second is a long time.
Yeah, I mentioned, we talked a bit about how long is too long, and that's 10 microseconds to 100 microseconds max. So it's not very long. There are some, for example, in some other languages such as .NET, it's usually they do something similar, but because of various parts of the design, it's more reasonable if you there it would be okay to spend a second before you yield back. But in Tokio, the impact on the tail latencies of your task, for example, if you are writing a web server, if you then measure how long does it take to respond, and then if you take the outliers, then your outliers is going to be really bad if you have things blocking the thread, and that's the problem.
Yeah, it's pretty interesting. I never really thought about Tokio being really this huge system for cooperative tasking. I never really thought about it like that. It almost makes it feel like we're bringing a garbage collected language into this, because that's where these kind of systems come in at to a certain extent.
Yeah, I think it's pretty cool that you can do all of this in a language that is not garbage collected.
Yeah, I think so too. I really, really like this system. I want to talk a little bit more about the constructs within Tokio. So you mentioned about the actor pattern, right? And I mentioned more than a few times about my experience with Elixir. And what I really like about Elixir is that you have this idea of supervisors that kind of watch these children, these worker tasks, and if they ever die, they can get restarted. Is there anything like that built into Tokio, so you can have this kind of really interesting kind of system?
Not really. The way it looks now, you kind of have to do it yourself. There are various actor frameworks out there. Actix was originally one. There are some others, and I'm sure some of them do stuff like this, but usually there are. So one of the reasons I wrote this blog post, the blog post is about how to do it with Tokio alone without any like dedicated actor system. And one of the reasons I wrote it is that the actual actor systems, they have a lot of like, for example, if you want to do anything async when you handle a message, some of the actor systems make this surprisingly difficult. And there are just a bunch of things like that. And yeah, and you just avoid that when using Tokio directly, because you don't have to deal with any traits or anything, and async traits are not that great right now.
So maybe you can describe like if I'm going to be because obviously I don't know if it seems like it's not true anymore, but it used to be that if you wanted to use actors, you'd want to use Actix, but it seems like Actix has kind of fallen out of favor recently.
Yeah, it's mostly a web library at this point.
Yeah, well, I mean, you still have Actix Web, but now they say Actix Web is no longer using Actix underneath. They just use the name for the most part. So,
yeah, I
but
guess. I think there maybe still be some sort of actor thing when you use WebSockets, but I'm not too familiar with Actix, to be honest.
Yeah, definitely. Yeah, that's right. That's I do remember that when you use WebSocket, they use Actix. But so if I'm going to be using like, what's it like to use the actor system within? If I'm using just if we're using just Tokio by itself, like what kind of things can I do? What kind of things can I not do? Because you're saying like if you use actor patterns like libraries, I think you mentioned, it's quite difficult in Rust at least. So if I'm going to be doing it your way, according to your blog post, if you don't mind to kind of give us a quick rundown about like what's the good things about using this method, what's the bad things, what can I do, what can I not do?
Yeah. So the main idea, well, the way I see it anyway, the main idea of using actors in asynchronous applications is that typically, like one of the main mistakes I see when people try to write game servers or chat servers is that they put all of their connections into a big hash map with user IDs and put a mutex around it. And this actually usually doesn't work out very well because you run into problems with now your connections are all inside this mutex. So if you want to access the connection, you have to lock the mutex, but now you prevent everybody else from accessing any of the other connections, and you run into problems. So what you do instead is that you spawn a task, and this task has exclusive ownership of the connection object. Nobody else can access it. And so the way you actually use the connection object is that you set up channels, message passing channels. So for example, you're going to create an MPSC channel, multi-producer, single consumer, and the actor task is going to have some sort of loop that receives messages, and whenever you receive a message, you do something to the IO connection. And similarly, the actor is probably also going to have some code to, whenever a message arrives on the connection, the actor can send a message to somewhere else. So that's the main idea. And then the article has a bunch of ideas for how do you do this without running into lifetime problems, and how do you write a nice API. I introduced a concept called a handle, which is like a struct that is a wrapper around the sender for the channel, and you can put nice functions on it and to get a nice API for your actor. But the central idea is really give exclusive ownership of your sockets to tasks, and then actors is just the best way to talk to such a task. Yeah.
Okay. No, I like that. I think it's definitely the way to go. The only thing that you have to worry about is if that one task that owns the resource ever gets too many messages that it can't reply fast enough, then you're in a real trouble.
I mean, so when do you run into this? So usually that would be because the connection is not keeping up, but that's not really an actor-specific problem. And so the way you can approach these kind of problems is that usually the channel that you use to send messages to the actor is bounded, And this means that you get what's called back pressure. So if the actor cannot keep up, then the sender will sleep until the actor is ready to accept your message. And this way you can avoid many of these issues. In some cases, you might want to, instead of like sleeping, if it can't keep up, you might want to do a trisend and then kill the actor if it can't keep up. But then just close the connection and like, sorry, dude, you're too slow.
What about when you're sending data, right? I mean, with if in an actor pattern, are you actually sending a reference to the same piece of memory, or are you actually taking a copy of it and sending it across?
So the values you're sending across the channel, they have to be owned. They can't have any lifetimes on them, because they have to be static. And so, for example, if you're sending, let's say, please send this string, we're writing a chatbot or whatever, like a chat room. Please send this string to the connection. Then you're either going to be having to sending an owned string by like ownership without sharing it. Another option is to put the string inside, say, an arc, and then you get reference counted sharing, and then you can send the same string to many actors. For example, if you have some sort of global message in your chat system that needs to go to all of them, then maybe that's more efficient. And you can do both.
Okay. That makes sense then. All right, that's pretty cool. I am quite interested in pulling in the actor pattern for Rust because of my background. I mean, nobody really wants to play around with mutexes and all that kind of stuff. It's much easier just to, send data and try to keep it.
I mean, I have lots of opinions about how to use mutexes too. And I'm working on a blog post to talk about this in the same way as I'm talking about the actor pattern in my other blog post. So that's coming up eventually.
Okay, I'll have to read this blog post then. So is actually what actually are you studying in school? You must have some kind of focus for a master's, right?
It's just it's like a mix of mathematics and computer science.
No specific part in computer science exactly?
I mean, the name of the master's is mathematical, like, what's the word? Mathematical computation and modeling. But, I mean, I'm not actually a data scientist, if that's what you're thinking of. So, I mean, right now I'm just taking ordinary algorithms courses and graph theory and stuff like that.
No, definitely not. I'm not thinking about data science at all. Data science is way over my head. I'm just curious about like
the name of the master sounds kind of like it, and I'm sure there are some people who take the master who do that, but you have a lot of freedom in what courses you're taking.
I was thinking more about like really getting into specifics about which algorithms are faster or slower, which ones make more sense. Maybe there's certain things that, like it. For me, I'm much more into the actor pattern, but I'm sure there could be times where actor pattern doesn't fit for every single problem, right? So it would be interesting to hear like
sometimes you do want a mutex instead of an actor. So for example, in the Tokio tutorial, we go through this project called Mini Redis, which is like a project designed to be a learning resource. And so in Mini Redis, so it's basically a Redis implementation, and the way we actually share the database is with a mutex around a hash map. And I think so actors are great for sharing IO resources. Often if you're just sharing plain old data, you might actually want a mutex instead. And you might even want a blocking mutex instead, which is what we do in Mini Redis. You could also use an actor if you wanted to, but a mutex would probably be more efficient.
Okay. So we went over some interesting crates, like the tracing crate, definitely console stuff, the metrics. Of course, we want to make sure that Tokio is 1.0 or past 1.0, but it's not quite done yet. What else is actually on the roadmap for Tokio coming up?
What else is on the roadmap? So, I mean, there's of course continued work on visibility with continuing to working on tracing Tokio Console, adding more metrics, hopefully adding some more topics pages. So one interesting thing is that we have an experimental implementation of I/O Uring, which is super great for file system I/O. The I/O implementation that Tokio and most other runtimes use nowadays does not really work for files very great. And I/O Uring is a solution to that problem. So what exists today is that there's a crate called Tokio Uring, which allows you to create a Tokio runtime with, like, basically the driver has an extra I/O Uring component. And you can use it to do file system operations in an async way, and it's pretty cool. I think eventually we're going to want to have Tokio's own file object use I/O Uring by default, but it's probably going to be a while until that happens. I/O Uring needs to be, be more mature, have existed for a longer time, that kind of stuff. But I think that's going to happen eventually.
So what exactly is the Uring? I didn't quite understand that.
So the way you currently, so I talked about the syscall earlier, which you use to ask the kernel to go to sleep and please wake me up when events happen. And the thing Tokio uses for this is called epoll. Now, new versions of Linux have introduced an alternative called I/O Uring. And so the main difference between the two is that with epoll, basically, so let's say you want to write to a TCP stream. The way you do it in epoll is that you attempt to do the write syscall, and then you get a, oops, that would block, let's not do that, and then you would yield to the executor. And then epoll would tell you when is this TCP stream ready to perform operations, and once it is, you can go back and try to do the read or write again. And so that's how epoll works. I/O Uring is a bit different. Here, you basically have a queue of operations that you can give to the kernel, and you can just add operations. You can say, please read 20 bytes into this buffer from this TCP stream, and then you can add another one. Please write these 30 bytes to this file. And you just throw them in the queue and say to the kernel, there's new stuff in the queue, and the kernel will go read it. And so this is cool for several reasons. So one of the reasons is that you're not actually performing a write syscall to do a write. You're just adding it to a queue, and the kernel will come and read it later. And so this means that you don't actually have to perform a separate syscall for every single I/O operation. You can fill the queue up with lots of syscalls, and then you can do a single syscall to say to the kernel, please go start all of these operations. And so that's one reason that it's cool. And another reason is that like because of this way that it works, there's no way that an operation could block if you submit it to this queue. There's no risk of blocking the thread here. And even if you do submit a file operation, please to a file in the file system, that won't block your thread either. And that's exactly the problem with epoll, because if you try to write to a file, then even if that would block because the file system is not ready right now or whatever, then epoll still thinks that it's ready. Because what epoll thinks about readiness is only stuff like, has anything arrived on this TCP stream at all? And the file data is right there on the disk. I can just go get it. And so it doesn't actually think that it's ready, even though it would be blocking to use the file. And so epoll just doesn't work with files. And what Tokio has to do now is to basically, it has a completely separate thread pool that you use with something called spawn blocking. And all file operations are offloaded to this separate thread pool. And this has a bunch of extra overhead, which makes file operations extra expensive in async than they would be in ordinary code, which is only something that applies to files. And it's not great. And so Tokio Uring is a way to get async file operations without using spawn blocking, essentially.
Okay. So you give it the queue, and then so the same thing would happen again, right? So so the original method is you give it something, you make a syscall, you try it, it says it's not ready, then you say, okay, let me know when you're ready, and it comes back and says, okay, I'm ready, and then you do that deed. Now in this case, you give it a queue, and then it's kind of like skipping the first step, like you said, and you're just saying, let me know when you're ready, and it'll just process it whenever it's ready.
There are actually two queues here. There's one queue with, here are the operations I want the kernel to perform, and then there's another queue where the kernel will put any results whenever an operation has finished. And you just throw operations into the queue, and the kernel will throw them back at you when it's done with them. And there's a way to go to sleep until any operations show up in the queue.
I'm just trying to understand, because of course these things can happen out of order, right? So when I think about queue, I'm thinking about ordered queue. So there's really no, okay. So how would it know?
You can think of it as a queue of things that it should start doing. And once it's started, they run independently, out of order. And when they complete, they come back in who knows what order.
Yeah, that's the part that I'm interested in, is the out queue, right? So when this task gets done, I mean, there's something at the other end that just spits it out and says, okay, who is this? And then that's me over there, and it kind of throw it to that person and say, okay, here we go. I'm just trying to think what that looks like underneath from the out queue side.
So basically, there's going to be we call it a driver, an IO driver for IO Uring, and it's going to, so you can put extra information, some sort of ID into the IO Uring operation, and you get the same ID back when it's done. And then you basically just have a hash map or something like that. And you look up, okay, so what operation was this? And then you can go send it to the right place.
Got it. That's how it works. Okay, that makes much more sense now. So that one's called the IO Uring. I wonder why they call it a Uring exactly.
So I called it a queue. It's a ring buffer.
Got it. Okay. Interesting. So basically, you're saying let me know if I understand this correctly. You can actually replace epoll with the IO Uring for IO operations in Tokio.
So in principle, you could implement that. The way it works with Tokio right now is that if you use the Tokio Uring crate, you would have both epoll and IO Uring. And the way Tokio...
So I was just curious, how would you choose which one you want to use? Go ahead.
Well, there would be one TCP stream type for epoll. That's the one in Tokio Net. And then the Tokio Uring crate would have another TCP stream type. And which type you use would then result in which driver you're using. And the way it would then, the way it would park is that you can actually tell epoll to wake you up if something happens on an Uring. And so you can tie them together in this way.
So Uring can actually reach back into epoll, you're saying?
Yeah, epoll accepts any file descriptor. It could be a TCP stream, something like that, but it can also be a Uring file descriptor. It has a file descriptor, and you can put it in epoll, and it will work. And then you can go look in the Uring for outqueue for what actually happened.
Okay, interesting. Now, what else is pretty interesting going on for Tokio Project is that there's also a web server coming out, right? I think is it Tower? I mean, so I see you kind of wrote on our question sheet, Axum, Tower, or Loom, right? So I have a choice. Mm-hmm. So can you tell us about these?
Yes, let's talk about them. So Axum is a new web framework library, similar to how Actix or Rocket are web frameworks. And it's written by someone on the Tokio team. It's actually somebody who's also in Denmark, which is quite cool. And the way it happened was basically that David got involved with Tokio, and then I think Carl asked him if he wanted to do a web server, and then he said sure, and then he made a web server, and now Tokio has a web server that's part of the Tokio project, like for real. There are some other web servers too, but they're not like part of the official Tokio project per se. Now, when it comes to Tower, so Tower is not web server specific. Tower is designed to be some sort of utility library for utilities that would work with any protocol. HTTP, what do I know, IRC, anything else. And Axum is actually the only, I think it's the only web server framework that actually uses the Tower utilities in how, basically in how you implement your web server. And you can actually use all of these reusable utilities from Tower in your Axum web framework. And if you look at any other web framework, for example, Warp, they're going to have their own concept, filter, what do I know, also. And the idea with Tower is that you can actually build these things in a reusable way, such that you can use them across many different projects. For example, we have a project called Tonic, which is some sort of gRPC thing, which is not a web server, it's like remote procedure call stuff. And it also uses Tower. And you can use the same like utilities for putting together web servers, both in Tonic and with Axum.
Yeah, I feel like now the web space for Rust is getting very crowded. I'm starting to trying to figure out when I would want to use which web framework nowadays.
Yeah, I mean, it's a good question. I honestly don't.
To me, I see basically two big camps. There's like Warp, and then there's Actix. Then now you have Axum, which is new to me. Also Rocket too, but Rocket is kind of on hold, I heard recently. I think the maintainer has some personal things going on where he's kind of parked the project a bit. But yeah, Rocket is very clear, right? If you want like a all in one kind of thing ready to go, like the Rails of Rust, you would go for Rocket. Nuts and bolts included, right? If you want anything else, which basically is everybody else, it's like, do I go to Warp? Do I go to Actix Web? Now there's Axum. It's a very good question. Like I'm starting to like, no matter what, you're going to be using Hyper. That's basically what I see. But beyond that, I don't know.
Yeah, everything uses Hyper under the hood. Honestly, I don't know what the best choice is. I don't actually work on web servers myself. And so, if you look at something like Hyper, it's a pretty thin wrapper around. No, what am I saying? If you look at something like Axum, it's a pretty thin wrapper around Hyper. And it's basically just like some sort of way to have some nice stuff on top of Hyper, so you can talk with, and so you can also use the Tower utilities. And Actix Web has, I think it's like a thicker wrapper, probably, is a good way to describe it. Yeah. But I'm really not the expert on which web framework should you be using, honestly.
But if you were to say which async runtime should we be using, do you have any idea?
Tokio.
I feel like there's just no comparison with other ones. I think there's like one other one that maybe should get mentioned. There's like a default async runtime, right? I think this is called async runtime or something. I forgot what the one that. There's another one like that I think the core team wrote, but it's kind of like, yeah, you can use this, but maybe consider Tokio. That's what I feel like they're saying.
So I'm assuming you're talking about async STD, and so the thing is, it's not written about it's not an official runtime. It's just another project that is competing with Tokio. So yeah, but it's not as big as Tokio, and it does many of the same things, but yeah, I think it is what it is. I think a lot of people are confused about the name because it sounds very official, but it's just as unofficial as Tokio is.
Yeah, definitely. Okay, I think we went through quite a lot of topics. I got you over here for over an hour. In fact, we spent like an hour and a half together, not including all the time that we recorded. Is there anything else you'd like to mention about the Tokio project, or maybe you want to have a call out for people to come help out in certain places? You want to make sure people know?
Yeah, I mean, if you want to get involved with Tokio, like, come talk to me or ask on the Tokio Discord. Like, there are places you can help and get involved. Absolutely. So the place I care the most about is, for example, documentation, writing more topics pages. But I'm sure there are also other things you could help with, or even some of the other projects. For example, Axum or Tower. You could also get involved with that kind of stuff.
Definitely very cool. And what's the best way to get in touch with you? Is that through Twitter or sounds like through Discord maybe?
Yeah, probably on Discord. If you post in the Tokio Discord, I will see it. I don't actually have Twitter, so that's not a very good way.
You're one of the few people in developer land who doesn't have a Twitter. I don't know why developers have Twitter.
Yeah, I quit a few years ago, and I'm very happy.
my marketing person was talking to me, I think yesterday. He's like, yeah, I noticed that most of our guests don't have any Facebook. I said, even I closed my Facebook. I got tired of all the kind of politics on there. And Twitter, I can just follow and unfollow people and don't have to worry.
I use Facebook. I think in Denmark, Facebook Messenger is the default messaging app these days. So yeah.
Definitely.
But I don't really use it for the, like, what's it called? Like the homepage. I mostly use it for messaging.
Facebook Messenger, you mean?
Yeah.
Yeah, it's pretty convenient. It's got quite a lot of good features in it.
Yeah, and it's what everyone else here uses. So.
Well, it's good to know. If I go to Denmark, I should probably have Facebook Messenger open. Okay. Well, thank you so much for making time to come on here. I really appreciate you kind of helping me to understand more about Tokio and letting us know there's more to Tokio than just Tokio itself, right? Tracing and Axum, which I don't think I heard about before. I've heard a little bit about Tower, and that's also interesting to hear what Axum actually is. It's building on top of Tower. And also confusing us about which web framework we should really take a look at these days.
But yeah, sorry about
that. It's okay, but I think Axum we should definitely give it a try. It sounds pretty interesting. I did find it interesting. I just looked at their page as we were talking, and they did say that, hey, we're just very thin layer on top of Hyper, so speed is definitely comparable to Hyper, and that's interesting to hear. And I mean, because every framework should add something to it. So in any case, yeah, again, I thank you for coming on. Yeah, maybe I'll have you back again sometime soon, especially if there's something new. Maybe when IOU Ring comes out as production ready, we can talk more about that. It seems like you're pretty excited about that project.
Yeah, absolutely. Well, it was nice to be on the podcast.
Yeah, and be ready to listen to yourself soon, right?
Oh no.
All right.